All right, we're going to look today at reducing radicals, but before we jump into that, we need to kind of go back and look at a couple things. One of them is the perfect squares. If you'll recall, when you square a number, it's taking it times itself. So I have kind of a list of all what we call the perfect squares, which is 1 squared or 2 squared, 3 squared, your results from that. So when I look at this list of perfect squares, I'm very interested in this list right here of all of these numbers that are actually what we call perfect squares, because they could be obtained by taking a number and squaring it. But really, more than that, the reason that I want them is because I can do the opposite. Instead of squaring, what we're really going to be doing today is square rooting, which is the opposite operation. And so what I'm doing is I'm backtracking. I'm taking those perfect squares and I'm taking them back to the number that you square to get them. If you have a perfect square and you try to square root it, it always comes out nice. So this right here is going to be our goal today, is to try to be taking square roots of perfect squares, because they're all going to come out nice. Now on each slide, I'll go ahead and keep our list of perfect squares there, because we're always going to be looking for a perfect square to take the square root of. Now you should have a note sheet in front of you that you're going to be filling out as we go through here. Each of these slides will match your note sheet, so you just fill it in as we go. Every once in a while you'll need to pause the video so that you can finish out a section of your note sheet. Okay, so here's our goal. These are square roots that we're taking today, and we start off and we just look at all the ones that are nice and pretty because they're taking square roots of what we call perfect squares. So if you take the square root of a perfect square, you're going to get a nice integer or a whole number. And so the square root of 49, well, you're just looking at what's the number that you square to get 49? Well, it's 7. The square root of 36, what do you square to get 36? 6. So we're just undoing that squaring process. Square root of 4 would be 2. Square root of 81 is 9. All right, take a minute, pause the video, you do those next 4. Okay, check your answers. I got a 5, a 9, a 4, and a 10. Those are all perfect squares, so they all come out nice. That's going to be our goal today. Each slide, I will keep a list of our perfect squares so that, because we're always looking for these particular roots. Okay, so here's what our deal is today. We're trying to reduce radicals that aren't going to be perfect squares. So we're going to be looking to try to break them down, kind of like we do with a fraction, where you try to reduce a fraction. We're going to try to reduce a radical. And so if you look at this first example, I had a square root of 45. 45 is not in my list over here on the right of perfect squares, so it's not going to come out nice. 45 is not a perfect square. But what I can do is break it down into 2 radicals, and I'm going to pick one of those radicals to be a perfect square. So in this case, I got the square root of 45. I broke it down to a square root of 9 times the square root of 5, because 9 times 5 is 45. But the square root of 9, well, 9 is a perfect square. It's in my list right here, and so it breaks down to a nice, pretty 3. And then you still have the square root of 5 that doesn't come out nice, and you're just multiplying those 2 together. Okay, let's try again. The square root of 32. 32 is not a perfect square, but it can be broken down to the product of the square root of 16 and the square root of 2. Okay, so the reason we choose 16 is because 16 is a perfect square from our list, and it's going to come out nice as a 4. The square root of 2 stays in there, it's not going to come out nice. And so my answer then is just 4 square root of 2. All right, let's try one more of these. The square root of 20. 20 is not a perfect square, but I come over here to my list of perfect squares and I'm trying to find a number that would go into 20 that is a perfect square. All right, if you look at your list, well, 4 goes into 20, because 4 times 5 will get you 20. Now you have to pick something that is a perfect square. It doesn't help me to choose 2 and 10, let's say, because neither 2 nor 10 is in my list of perfect squares, and those aren't going to come out nice. You have to find a perfect square so that it will come out at least partially nice. So this part will come out nice. The square root of 4 is just 2, and then the square root of 5 just stays there. All right, so let's try several of these. I've got a list kind of problems here, 8 practice problems for you to do. We'll do the first one together and then you finish them up on your own. But we're looking at trying to find a perfect square that will go into each one of these so we can break it down. So on number 1, I've got the square root of 50. 50 is not a perfect square by itself, but it could be broken down into, and I'm looking at my list trying to find, 25 goes into it. So then you would take this as the square root of 25 times the square root of 2. That gets you 50. And the reason we choose 25 is because it comes out as a 5, no radical. And then the square root of 2 is the part that still stays there because it does not reduce. Okay, let's try, I don't know, let's just try one more together. I got a square root of 40. Okay, so I'm looking at my list, going through what would go into 40. And, you know, I always look and see, 4 would go into it. But anytime I see 4 that goes into it, I always check to see if 16 goes into it. You always want to pick the largest one. So does 16 go into 40? And you'll have a little bit of calculator work maybe today to try to see what goes into a number. 16 does not go into 40 nicely, so I'm stuck with leaving it at a 4. 4 times 10 is 40. All right, the square root of 4 comes out nice. It's just a 2, and the square root of 10 stays in that radical. Okay, so just a hint, every time you check it and you say, 4 goes into it, always check to see if 16 will go into it also, because you always want to pick the largest one. All right, you pause the video and go ahead and finish up these next 6 problems on your note sheet. All right, take a minute and check your work. Mark any of them wrong that you didn't do, and then we need to probably go back and look at why. So take a minute and check your problems. Let's talk about a couple in there that were kind of tricky. Really, the very next one that I gave you is one that you had to be careful about. Did you maybe pick 4 and 20 as an option? Okay, well, that would be okay, except it's kind of like when you reduce a fraction, but then you didn't reduce it all the way and it keeps reducing. Same thing with radicals. If you don't pick the biggest perfect square, then it's not reduced as much as it can be. So make sure you pick the biggest one. Okay, here's another one. 4 goes into 32, but so does 16, so be sure to pick the 16. Okay, I didn't mean to put a bunch of tricky ones on here, but I see number 7 is kind of like that too. Maybe on 72 it's tempting to go with a 9 and an 8 because 9 is a perfect square. But even better, 36 goes into that. You start to get kind of familiar with some of these numbers because you kind of keep coming across the same ones over and over. And 32 is kind of one of those. 72 is one of those. Okay, let's keep working. Okay, so let's look at some problems here that maybe have a coefficient on the radical. That's the number that's out in front that gets multiplied. All right, on all of these examples, I actually have this extra number in front of the radical. And all you do with that is you just keep bringing it down. It's being multiplied, so kind of like your very last step, you'll actually multiply that number into whatever the radical part that you've reduced. So let's look at this first example right here. I've got a 7 square root of 45. The 7 just gets brought down, and then the square root of 45, I break down into the square root of 9 times the square root of 5. And again, I choose 9 because it's a nice perfect square and will come out nicely as just 3. The square root of 5 part does not reduce. Okay, well what happens though, now that you have this 3 that you got out of there, and it's being multiplied by this 7 out in front, you actually can then go ahead and just multiply those two numbers together, and it becomes 21 square root of 5. Okay, let's try one where we have to do a little bit of the work. So here's this negative 5 square root of 32. So if you look at this, I just bring the negative 5 on down. There's that 32, remember you break that down with a 16, not a 4, but a 16, and that would be what? 16 times 2. Okay, so the square root of 16, that one comes out nice. That's just 4, but the square root of 2 stays put. Okay, and then your very last step, since you were able to pull some of that part out of the radical, you have that 4 times that negative 5, so your final answer would be a negative 20 square root of 2. Okay, let's try another one. Even less of it done, so we have to do more work here. And so when I look at this, I've got the 6. I brought the 6 down, but I've got to figure out how to break down the square root of 20. So I'm going back to my list here of perfect squares and trying to find what's the perfect square that'll go into 20. Look through your list. And 4 goes into 20. You always want to put that perfect square first because it's going to be the part that comes out clean that's going to multiply by your coefficient. So I know it's 4 and 5, so be sure to put the 4 first and then the 5. Okay, so the point of picking 4 is because it's going to come out clean as just a 2, and then the square root of 5 stays inside the radical there. And now we're able to actually multiply these two numbers together, so you have a 12 square root of 5 as your final answer. Okay, so now we're going to practice some of these where you have that coefficient on it. You should always have 4 steps on these. Don't start doing shortcuts. As soon as those shortcuts happen, I promise that's when the errors start. So I want to see 4 steps every single time if there's this coefficient here. All right, so I'm actually going to do number 3. It's actually trickier than number 1 is there. And so if you look at number 3, I've got the 4 that's pulled out, and then I'm trying to break down the square root of 48. So looking at my list of perfect squares over here, I wonder, okay, what would go into 48? Now, the obvious one, the one that jumps out at me is 4. But remember what I said, that if 4 goes into it, try 16, and so check it in your calculator. Does 16 divide nicely into 48? And so if you divide it out, it does actually. And so instead of using 4, we're going to use 16. Remember, always put the perfect square part first, and it's 16 times 3 will get you a 48. Okay, so then you bring the 4 down, and then the square root of 16 breaks down nicely to just 4. And then the square root of 3 stays inside the radical. All right, and then since you managed to get some of that out of the radical, you get to go ahead and multiply. 4 times 4 is 16, square root of 3. There's your 1, 2, 3, 4 steps that I want to see on all these problems. Now, if there's not a coefficient in front, then you won't have that last step, so you'd only have 3 steps on those problems. Box in your final answer for me. Okay, so you have 7 more problems here that I want you to practice, and actually to tell you we're going to do one of these other ones also because I don't have any of the work there. I want to make sure that you understand what it is I'm looking for from you. So let's say we do, I don't know, let's try number 7. Okay, so I'm going to go ahead and I start off and I bring the 2 down. And then the square root of 63, I'm going to break down into square root times square root. All right. So then I do some work, and I go to my list of perfect squares, and I say, what will go into 63 nicely? Really need to know your times tables here. It helps you, it makes it go much faster. So 9 goes into 63. And 9 times 7 is what will make that happen. Okay, so then you bring down your 2. Your square root of 9 is going to come out nice. That was the whole purpose of picking it. And then the square root of 7 stays put. And 2 times 3 is 6, square root of 7. There's your final answer. There's your 1, 2, 3, 4 steps. Okay, actually we're going to do one more of these because I saw there's a tricky one on here, this number 5. Because here's what happened, is I'm sitting there thinking, what's the perfect square that goes into 36? Well, geez, when I look at my list, 36 is a perfect square. Don't make this harder than it has to be. It's bring down your 10, and I am not going to do square root on this because 36 is a perfect square. I'm not going to do a whole bunch of extra work. The square root of 36 is just 6. It comes out nice. That's just 60. And that means that there's no radical part left at all, because what I had in the radical was one of my perfect squares. So kind of be looking for that to pop up every once in a while. Okay, go ahead and pause the video. You finish up these other 5 practice problems. Okay, now that you have this, go ahead and pause the video so that you can check each one of your problems and make sure that you agree with mine. If you disagree, then go back and check and see where you went wrong. But go ahead and pause it so you can see this screen as you're checking. Once your note sheet is completed, go ahead and show that to the teacher to show that you've worked through those, you know what you're doing, and then pick up a homework worksheet. Use your note sheet as you go through that so you have that handy. You want to have that list of perfect squares handy so that you know what numbers it is you're looking for. Good luck.